All right, last question. Wild animal preserve can support no more than 130 elephants. 31 elephants were known to be there in the preserve in 1980. Assume the rate of growth of the population is this differential equation where T is time and years. Find a formula for the elephant populations in terms of T. And we could do a lot of calculus stuff on this, and some of the calculus is really complex. And in fact, I had you do problems like that in class. But also recognize this. This equation right here is equivalent to the logistic function, which you have solved for. So it's okay to use as this equivalent logistic function. P is equal to m over 1 plus, what's going on with my tablet here? 1 plus a times e to the negative mk times t. All right. That's the logistic function that models the population that results from this differential equation. Okay. Well, some other things that we've learned that we can apply. Number one, if we're talking about the differential equation dp dt, what we're saying is we've got some constant times p times the maximum carrying capacity minus the population. All right, that's the formula that the differential equation given to us is represented by. Okay, which is kind of goofy looking. But here's what we know. This guy right here, we know that that guy is K. This guy right here, we know that he is M. And so we can use that to help us solve this problem. The first thing that we can do is we can figure out most of this exponent right here by just simply finding out what M times K is. And when you do that, you get this. If I need M times K, what I'm going to end up with is 0.0005 times 130. Okay, that represents this part of our equation right here. So when I punch that into my calculator, I get 0.065. Okay, that's this guy right there. I also know that M for this problem is going to be 130. Okay, so I've been given some information to start setting up, because this is the equation I'm going for. I want to know a logistic equation that models this elephant population, and logistic equations are great for modeling populations because it allows for us to put an upper limit on a population that can fit onto a particular spot. So let's start looking at what we've got here. I've got P equals 130 over 1 plus some initial amount we're not aware of yet times e to the negative 0.065 times t. Okay, now again in class we solved out we would solve these out. They're tough. They're very tough. But using that knowledge that we've gained in class through the hard work, through the calculus, we can now use the algebra. We know this works. So what is the only piece of information that we need to find? And the only piece of information that we need is A. We just need to know that initial amount. And in fact, that is that's a primary part of this question. Okay. To find that A value, use what the problem has given us. The problem told us that in year 0, that would be 1980, there were 31 elephants. Okay. So when T is 0, then P is 31. Well, our problem takes a small change. We have 31 equals 130 over 1 plus A times e to the negative 0.065 times 0. That means e to this whole power is just 0. So e to the 0 power is 1. Well, my problem just got a lot easier. I wind up with this guy right here. And so 31 plus 31a equals 130. I can solve that. That's not a hard thing to solve. So 31a equals 99. Divide both sides by 31, and a equals 3.1935. 31935. Okay. Well, if I'm going to come up with a model, a formula that tells me elephant population, I need P to be a variable and T to be a variable, because I want to be able to go, okay, in 25 years after 1980, what happens? Or in 30 years after 1980, what happens? Or how long will it take for my population to reach 129? So I can get a formula from that. And the only thing missing is A, which we just discovered. So the formula that models what we're looking for is this. P equals 130 over 1 plus 3.1935 times E to the negative 0.065 T. And there you go. That's really all you need to do. Now, if you want to solve this guy out using solving out the differential equation that we started off with, you are more than welcome to do so. You'll still get the exact same numbers. And there'll be a few more steps in there, and that's okay too. We've done a lot of difficult integration in this section, so I thought, you know what? Let's see how we can work one without all that. But you're more than welcome to do it anyway. It's great for you to understand. Okay, so there you go. There's your test review. Good luck.